In problem number 9, we are going to estimate the area under the curve in figure 15 on the interval 0 to 1.5 using the right hand, left hand, and midpoint approximations. And these little sixes here mean we are going to use 6 subintervals, which means our n is equal to 6. Since we have the interval from 0 to 1.5, our delta x is then b, so 1.5, minus 0, which is a, all over 6. And that's equal to 1/4. Okay? So here is a blown up picture of figure 16, and we will have intervals of 1/4 of a length in width, here, here, okay. And our first rectangle here is going to have a width of 1/4, and using the right hand approximation, we will go to the right hand side of this interval and estimate this height right here and call that the height of the rectangle. I'm going to estimate that to be the height of this rectangle to be 2.4. We move to the next rectangle. We go to the right of that interval. We draw in our rectangle. So here's our first rectangle. Here's our second rectangle. I'm going to estimate this height to be 2.25. 2.25 plus next subinterval. Go to the right side. Draw over our height. And that height here is going to be 2. So we have 2.4, 2.25 plus 2. Right hand side of the next interval defines the height of the next one. And let's see, 1.6, I'm going to say that is. Plus right here. This is a height of approximately 1, and this right here is a height of approximately 0.6. Okay, so the width times the height of each one of these rectangles will give us the approximate area underneath this curve, which happens to be an underestimate. So again, we're approximating these height values, so this should be an approximation here. And after I plugged it into my calculator, I got 1/4 times 9.85, which is equal to 2.4625. So the area underneath that curve is somewhere greater than 2.4265. Then if I copied it again, and using the left-hand rule, we have these same subintervals of 1/4 of a length in width, but this time we're going to use the left-hand side of the interval. So this one we haven't approximated yet. I'm going to say that it's pretty close to this one, so I'm going to use it as 2.4 again. This height right here, oops, excuse me, for the second, we go to the left-hand side of the second rectangle, and we approximated this height right here in the right-hand side to also be 2.4. So I'll add 2.4 here. Then the right-hand side of our third rectangle gives us the height. And so this point on this curve is approximately 2.25. Again, to the right for the next rectangle, and that's approximately 2. The fourth, no, this is the fifth rectangle. The right-hand side of the fifth rectangle is approximately has an approximate height of 1.6. And the final rectangle has an approximate height of 1. Notice I use the same approximate heights as I did in R6. So, so I add that all up, and that's equal to 1/4 times 11.65. Now this 1/4 is delta x, or the width of each one of these rectangles. And these are all the heights. So that's equal to 2.9125. Now we know, if you look at this, we have an overestimate of the area. In the right-hand approximation, we had an underestimate. So we know that the actual area is somewhere between this 2.5 and this 2.9. The midpoint rule is our next one, and it will actually give us an even better approximation. I won't really know if it's an overestimate or underestimate unless I actually calculated or had a way to calculate the exact area. Which you can if you take the number of subintervals and let that go off to infinity. But again, you're still approximating these heights since we don't have an actual function. But so here we need to go to the middle of each one of these intervals and estimate the height, and then create our rectangle. So I'm going to estimate the height at the midpoint between 0 and 1/4 to be still about 2.4. So 2.4 plus, and then we come to the middle of this one. So the middle of this one, sorry, of the second rectangle is, I'm going to say 2.3. The middle of the third rectangle is about 2.2. The middle of the fourth rectangle is about 1.8. The middle of the fifth rectangle, I would say it's about 1.3. And again, your approximations may very well not be the same as mine, and that's okay, as long as you're not saying that this is approximately 1, because this line up here is 1, and that's too far away. That's a bad approximation. I'm actually going to say it's 0.8. We add those all up, we get 1/4 times 10.8, which is equal to 2.7. And thankfully that falls in between 2.9 and 2.5. All right, hope that makes sense.